Welcome everyone. Welcome to Physics by Aaron. I'm very happy to welcome you all in our free foundation physics course. In this course, in 15 days, I will be covering all the topics which are needed for your all the basics that you might need for your competitive physics exam. For example, IIT JAM, JEST, TIFR. I hope that you have been enjoying the foundation physics course till now. We are almost towards the end of our course. 3 to 4 days are remaining in our free foundation physics course. In the last 2 lectures, I started rotational motion and I started covering center of mass. So we studied what is center of mass, how do we calculate it, and then we saw the motion of center of mass. Today's topic is very important. I think you should spend a good enough time for this. I have given almost 30 problems in my notes, which you can see on our website and an app. So you should try to solve them all, because the collisions is a topic which directly comes in the exam. So by the end of this lecture, I will also discuss few TIFR PYQs as well, because I really want to give you a feeling that, okay, the questions are actually coming in exam. Whether it is GATE exam, NET exam, TIFR exam, JEST exam or JAM exam. In all those exams, collisions problems are directly being asked. So let's see what collisions is. So collisions is an isolated event in which strong forces act between 2 or more bodies for short time. So it is an isolated event. It means no external force is acting on a system. Second, the strong force acts between 2 bodies. So whenever 2 bodies collide, let's say you are going on a road and 2 trucks collide with each other. An unfortunate incident happens, and that collision, which means the 2 trucks will exert a very strong force on each other. And that force will be for very short time. The collision time is usually small. But this is an isolated system. Those 2 trucks are exerting force on each other, but on a combined system of the 2 trucks, no external force is acting. Okay, ideally. So isolated event, it is an isolated event in which 2 or more objects experiencing force due to each other. Now, it is not necessary that collision should have a physical contact. Collision can happen even without physical contact. Hopefully you remember Rutherford experiment. What is Rutherford experiment? So alpha particle is coming and it is deflected from the nucleus, gold nucleus, you remember. So it means without collision, the alpha particle scatters. Why does alpha particle scatters? Because of the force between nucleus and alpha particle. This phenomena can also be considered as collision. Collision does not necessarily means that it should have a physical contact. It can also be contactless. Okay, but as we know, the collision can also be contact collision. So, for example, in this case, a ball is sliding down the inclined plane and it hits the ground. So this hitting the ground is a collision. Okay. So whenever we talk about collision, a very important parameter that comes into play is coefficient of restitution, which is given by small e. It is defined as the velocity of separation along the line of impact divided by velocity of approach along the line of impact. So now I will spend some time in understanding this definition even more, because this is just a definition. But what do I mean by this? So in order to understand the real definition of coefficient of restitution, we have to understand line of impact. What is line of impact? So line of impact is a line passing through common normals to the surfaces in contact. So for example, let me just give you examples directly so that you can understand this English which I have written here. So let's say there are 2 bodies which are coming and colliding with each other. So the line which is perpendicular to both is known as line of impact. Line of impact. So you can think like that collision is happening along this line. So the line of impact is a line which is perpendicular to both the surfaces. Similarly, let's see here, there is an example. So first ball is coming from this side and second ball is coming from this side, and they will collide at this point. So you can really imagine if it reaches here and it reaches here, so both will collide. So when they collide, you see the perpendicular which is common to both is known as line of impact. Similarly, in the third case, so ball is dropped and it will hit the inclined plane. So once it hits the inclined plane, what is a line of impact? Line of impact is a normal which is perpendicular to both. So this is a perpendicular to incline as well as to the sphere. So this is the line of impact. So line of impact is nothing but a perpendicular to both the surfaces between which the collision is happening. Okay, now let's understand what is coefficient of restitution. Okay. So let's understand with the simplest example, then we can move on with the more tougher examples. So let's say there are two bodies which are approaching each other with V1 and V2. So their approaching speed is V1 plus V2. And once they collide, they will keep on going with V1 dash and V2 dash. So yeah, their separation, they are separating from each other at the speed of V2 dash plus V1 dash. So if I divide V2 dash by V1 dash with V1 plus V2, I will get coefficient of restitution. So it is simply the ratio of how fast they are separating divided by how fast they were approaching each other. So initially they were approaching. So what was the speed of approach? So what was the speed of approach? And afterwards they are separating. So how fast they are separating? So if you take their ratio, then it is known as coefficient of restitution. And you always have to remember, whenever we see the separation on an approach, we see it from the line of impact. How fast they are approaching the line of impact, or how fast they are separating away from the line of impact. And how do you see the line of impact? I have already shown you with the 3-4 examples. Okay. Now, let's come up to the questions and or a basic sort of knowledge that you might be needing. The direct formulas that you might require in order to solve many problems of collision. So let me change the color of my pen so that you don't get confused. So you have two objects. One is mass m1 and m2. Mass m1 is moving with velocity u1 and mass m2 is moving with velocity u2. If we want them to collide, then it is very basic that u1 has to be greater than u2. So this body has to come and collide to this body. So u1 has to be greater than u2. Then in that case, they will collide. So let's say they collide. So they collide with each other. And after the collision, their velocities will change, obviously. So their velocities will change. So mass m1 is now moving with velocity v1 and mass v2 is now moving with velocity v2. So if you want to avoid that they should not collide again, then what should happen? That now v2 should be greater than v1, so that it is always greater than v1. So now they will not collide again. Okay, so this is our basic approach. So now let's see what is coefficient of restitution. Okay, so you can clearly see what is your velocity of separation. So your velocity of separation after the collision will be v2 minus v1. So you have put it in the numerator, v2 minus v1. What was the velocity of approach before collision? How fast they were approaching each other? It was u2 minus u1. How fast they will be covering the distance between them? That will be u2 minus u1. So v2 minus v1 divided by, I think it will be u1 minus u2. Yes, u1 minus u2, because u1 is greater than u2. Okay, so they are separating after collision at the speed of v2 minus v1, and they are approaching each other before the collision at the speed of u1 minus u2. So your coefficient of restitution will be separation speed divided by approach speed. From there, you can easily get that v1 minus v2 is equals to minus of u1 minus u2. So nothing I have done here, just took the negative sign out and I have written like this. That's it. So this is a formula that you should always remember, that final velocity is equals to minus of E into minus of initial velocity. So v1 minus v2 is always equals to minus E equal u1 minus u2 in case of head-on collision. So this kind of collisions are known as head-on collision. Head-on collision means they both are in the same line and they collide with each other and keep on moving in the same line. So entire motion is one dimension. So this is known as head-on collision. So this is very important formula. Another important concept in this case is, in the last class I mentioned that collision is like an internal force. Collision is an internal force. No external force is acting on the system. They both are experiencing force due to each other, but these forces are internal between them. So the total momentum of the system will remain conserved. this we discussed in detail in the last class. Whenever there are only internal forces and no external forces acting, the total momentum of the system will remain conserved. So second equation which we will get is initial momentum, which is m1 u1 plus m2 u2 will be equals to final momentum, which is m1 v1 plus m2 v2. So your initial momentum is exactly equals to the final momentum. So this is your equation number 2. So equation number 1 and equation number 2 are usually used in the problems to find many things. So let's say I give you some bodies, some masses, some velocities, and I ask you what will be the final velocities. So all those questions are solved using these two equations. Number 1 equation and number 2 equation. So we use the definition of coefficient of restitution, and also we use the definition of conservation of linear momentum in order to solve the problems. Okay. Now I want to discuss about types of collision. That what are the different type of collisions which can take place. Number 1 type is perfectly elastic collision. In perfectly elastic collision, the linear momentum and kinetic energy. This is very important concept, that linear momentum and kinetic energy of the system remain conserved. So whatever is your initial momentum and whatever is your final momentum, they will be equal. Similarly, whatever is your initial kinetic energy and whatever is your final kinetic energy will also be equal. So this you should always remember. In perfectly elastic collision, this will happen. And in perfectly elastic collision, the value of coefficient of restitution will be 1. Okay. What is an example of your perfectly, almost, there is no collision which is 100% perfectly elastic, but there are some collisions which are very close to perfect elastic. For example, Newton cradle. So this is a Newton cradle that you might know. That how do you see this? So if there are, let's say there are 1, 2, 3, 4, 5 balls. So if you displace first ball and then let go the ball, then it will hit and only one ball from this side will move. So it means one ball displaces one ball. So it is kind of a perfect collision. So if you would have displaced 2 balls, then from here also 2 balls would have displaced. So one ball displaces one ball, 2 balls displace 2 balls. So this is known as the perfectly elastic collision. Similarly, billiard balls, you might have played billiard. Then in those also the collisions between the balls is very perfect, almost perfectly elastic. So all these examples are the perfect elastic examples. You should remember that no collision is 100% perfectly elastic, but there are many collisions which are almost elastic, which means E might not be 1, but E is roughly 0.95. This kind of collisions are possible. Okay. Then there is another end of this spectrum, which is known as perfectly inelastic. So in perfectly inelastic, linear momentum will remain conserved. Always remember, linear momentum always remain conserved. Linear momentum is never not conserved. Whenever your external force is 0, the linear momentum is conserved. So even in perfectly inelastic collision, the linear momentum is conserved. However, the kinetic energy is not conserved. Okay, in this case, E is 0. So your value of coefficient of restitution will be 0. What are the examples of perfectly inelastic collision? So let's say you have some jelly in your hand and you hit it on the wall. So that jelly, what will that jelly do? That jelly will get stuck on the wall. So whenever something gets stuck after the collision, so let's say you have a jelly in your hand and you hit it on somebody and that jelly got stuck. Okay, so whenever something is stuck after the collision, that kind of collisions are known as perfectly inelastic. So always remember that the examples in which the things are stuck are known as perfectly inelastic collision. Okay. For all other collisions, so there is never perfectly elastic, there is never perfectly inelastic. The collisions are always in between. So for all in between collisions, the E lies between 0 and 1. So E lies between 0 and 1. Okay. So 1 is for perfectly elastic, 0 is for perfectly inelastic, and for all other, it is between 0 to 1. Okay. Let's move to the next part. I want to explain some of the problems so that you actually get a feeling that how to solve the problems of collision. So let's do it. So you have three bodies, M1, M, A, B, and C. All of these three has same mass. So what happening is your body A is moving with velocity U. It goes and hit body B. And then that body goes and hit body C. And in the end, when everything gets settled down, what is the final velocity of all three bodies? This is what is being asked. So there will be two collisions. One collision will be between A and B, and then the second collision will be between B and C. So let's understand these collisions one by one. So let's see the collision between A and B. So this is your scenario. So it has been given to you that the collisions are perfectly elastic. It means E is 1. That is given to you. So let's see. So before collision, A was moving and B was at rest. So A was moving and B was at rest. So A goes on and hit the B. So after hitting, A will have velocity V1 and B will have velocity V2. Let's assume this. So first rule, let's conserve the momentum. So what we will say MU1 plus MU2 equals to MV1 plus MV2. MU1 means, so I can cancel this MM because it is common. U1 is U and U2 is 0. Similarly, here it comes V1 plus V2. So I get my first equation, which is U equals to V1 plus V2. Very nice. Then the second equation. What was the second equation which I told you? Second equation which I gave you. Let me write it. It is inverse actually. So the second equation which I gave you was V1 minus V2 equals to minus of E U1 minus U2. Fine. So this was your second equation. So it means your value of V1 is V1, your value of V2 is V2, your value of E is 1. So you will get -1 here. Your value of U1 is U and value of U2 is 0. So you will get U equals to minus V1 plus V2. So this is your second equation. So you get your first equation, you get your second equation. You can solve this equation. Once you can add both and another time you can subtract both. If you do this, then what you will get is that your V2 is U and your V1 is 0. What do you mean by that? V1 U, V2 is U. It means after the collision, your second body is moving with you and your first body has stopped. So I want to make this point very, very clear. Whenever one object is moving with velocity U and other object is stationary and both has the same mass. Okay, so the both bodies has the same mass. First body is moving with velocity U and the second body is at rest. So whenever they will hit, the first body which was moving will come to rest. So first body came to rest and the second body will start moving with same speed. So what has happened is actually that object A has given object B its speed and it has came to the rest himself. So A collided with B, A came to rest and B started moving with the same speed. So this is what happens when the two equal mass bodies collide with each other. And one body is moving with U and other body is at rest. Okay, now this actually made our second case simpler. Now, what will happen after first collision? So your A is at rest now and your B is now moving with U. And this is your C. Now what will happen? You can see here. So what will happen now? This B will go and hit C and B will come to at rest. And now C will start moving with velocity U. So finally what will happen is A and B both will be at rest and C will be moving with the speed of U. So after doing the mathematics in first part, I can directly say about the second collision. So after first collision, what was happening is A was at rest and B was moving with velocity U and C was at rest. So after collision between B and C, what will happen is B will also come at rest and C will start moving with velocity U. So this is a very simpler case which we can understand. Okay. Now, what if the masses are different? This was a case when I said that mass is same Oh, no, not masses are different. Masses are still same. Sorry, I'm very sorry. But the collision is not elastic. It is not elastic collision. E is not 1. E has some value. E has some other value. What about that? So again, the same situation. Your body of mass m is coming with velocity u. Let's say it is u. And the second body is at rest. After the collision, body 1 will have mass velocity v1 and body b will have velocity v2. We can directly find the velocity v1 and v2 using these formulas. So v1 is 1 minus e divided by 2 into u, and v2 is 1 plus e divided by 2 into u. So you don't have to do any complex mathematics. Whenever you see such kind of system, you can directly use this formula. I will suggest every one of you to remember this formula by heart. Very important. This makes your task very easy in the actual exams. Okay. So these concepts you should be knowing very directly that, okay, but if we have E, then these will be the velocities. But let's say the collision is perfectly elastic, then what will happen? First body will stop and second will start moving. But let's say it is not perfectly elastic, then what will happen? You will have velocities v1 and v2, which is given by these formulas. Remember, first body was moving, and second body was at rest. And after the collision, both are moving with velocities v1 and v2. Okay, so this is a direct formula that you will be needing to use in the many questions. Okay, let's try to understand one example. So the example here given to you is, there is a ball of mass m. So there is one ball which has mass m and it is moving with velocity speed v. It makes a head-on collision with another identical ball at rest. So this is a similar kind of example that you have seen in the previous formula, that you see that object 1, which is at mass m, is moving with velocity v. It goes and hit another body which is at rest. Both the bodies are identical, which means the masses of both the bodies are same. After the collision, what will happen is both bodies will start moving. First body will have velocity v1 and second body will have velocity v2. Now what is given to you is the kinetic energy of the balls after the collision is 3/4 time the origin. So let's start understanding this problem. So the the final answer which we were asked is, what we want to find is the coefficient of restitution. So we want to find the value of E. So let's start solving this problem. The first thing which we use is conservation of momentum. How do we conserve the momentum? Initial momentum equals to final momentum. So from here you can simply see your velocity comes out to be, your initial velocity is equals to v1 plus v2. This is your equation number 1. Very simple equation. You don't have to worry about it. Now the second condition which is given to you is that final kinetic energy is 3/4 times initial kinetic. So what is your final kinetic energy? Half mv1 square plus half mv2 square. And what was your initial kinetic energy? Half mv square. Because second body was at rest, so its kinetic energy was 0. So from here you can see the equation comes out to be v1 square plus v2 square equals to 3/4 times v square. Now we know one thing, that in the previous formula we studied that velocity v1 and velocity v2 will be 1 minus e by 2 v and 1 plus e by 2 v. So if I put these values here, then I can simply find the value of E. So I just have to simply put the values of these things here and I can find the value of E. And that will come out to be 1 by root. As simple as that. So you see, knowing the direct formula actually helped us a lot. Otherwise, what we would have to do? We have to solve the problem equation number 1, equation number 2, find the value of v1, v2, then do our formula of E equals to separation and approach, ratio of separation divided by approach, and then we would have got an answer. But no, if we use these formulas directly, our question become quite easy. Okay, so remember these kind of formulas because these actually help in your exam to solve the problems very fast. Okay, Now let's come to another example, very, very important example. Right now we were studying everything in one dimension. So particles were coming in one direction and they were hitting each other and they were also going away in the one direction. But now we change something. What we change is, let's see. So we have two particles. So particle A and particle B. So they are on a horizontal plane, which is frictionless. Okay. If a particle A, which is 1 kg, so particle A, which has a mass of 1 kg, coming with the speed of 10 meter per second and hits the particle B, which has a mass of 2 kg. After the collision, they both moves at an angle of 45 degree. So this is your situation. So your particle is coming. So this is your M1 coming. After collision, your object A goes in this direction and your object B goes in this direction. So this was before collision and this was after collision. First thing we want to know is the line of impact. How do we find the line of impact? So there is one short trick to find the line of impact. So that short trick is, if one body is moving, let's say your one body is moving and other is at rest. So this was a case, this is our case, one is moving and another is at rest. In that case, the line of impact is along the motion of body at rest after collision. So what he wants to tell is, after the collision, in whatever direction your body at rest will go. So the body at rest is B. So after collision, body at rest will move in some direction. So in whatever direction it moves, that direction will be the line of impact. So let me show you here. So this was your B and this was your A. After your collision, your B goes in this direction. So in whatever direction your B goes, the body which was at rest, in whatever direction it goes, that direction will be your line of impact. So always remember this situation. So we find out our line of impact. So this yellow line is our line of impact. Okay. So once we know our line of impact, then we can easily resolve our vectors. So in this direction, your velocity B is going. In this direction, your velocity A is going. And both are making an angle of 45 degree with your x-axis. So now we are asked about two things. Number one, what is the velocity of BA and BB after collision? And what is your coefficient of restitution? Okay, let's solve. So first of all, we will conserve momentum along x-axis. So let's conserve it. So your body was initially coming at x-axis, along x-axis, and then your body move in these directions. So the x component of VA is VA cos 45 and the x component of VB is VB cos 45. So how you will write this then? Initial momentum, which is MAU. So initial momentum of body A, that will be MAU, because body B is at rest. So your initial momentum is MAU equals to MA VA cos 45 plus MA VB cos 45. So this is your initial momentum along X and this is your final momentum along X. If you make them equal and put the values of mass, you can put the value of masses, it is given to you. You can put the value of velocity, that is also given to you. Then you will get VA plus 2VB equals to 10 root 2. So this is your equation number 1. Now let's conserve the momentum along Y. So you can clearly see your initial momentum along Y is 0. It is 0. Why? Because body was initially moving along X. So there was no initial momentum along Y. But there is a momentum, final momentum along Y. What is that? For this VA, the Y component is VA sin 45. And for VB, your Y component is VB sin 45. Okay. So your final momentum will be MA VA sin 45 minus. Why minus? Because this side is negative. So minus MB VB sin 45 equals to 0. If you put the values, you will get VA equals to minus 2VB or VA equals to 2VB. So this is your equation number 2 and this is your equation number 1. So you have two equations and you have two variables. If you just put the values in each other, you will get the velocity A as 10 by root 2 and velocity B as 5 by root 2. This is a simple algebraic step, anyone can do it. Okay. So first question we solved. So the first part was, what are the velocities after collision? VA and VB. So we got VA and VB, which is 10 by root 2 and 5 by root 2. The second question is actually much more interesting than the first question. What is the coefficient of restitution? I again want to repeat the definition of coefficient of restitution. It is velocity of separation along, I want to repeat this sentence quite many times. It is a velocity of separation along the line of impact divided by velocity of approach along the line of impact. Okay. So let's first see the approach velocity. So velocity of approach along the impact. So this yellow line is your impact line. Just to make a diagram beautiful, I can make this yellow line parallel here as well. So this is your initial body coming up, and just to make the drawing simpler, I have drawn this yellow line here as well. So you can clearly see that this was your initial speed. But we are not interested about the initial speed. We are interested about the initial speed along your line of approach. You don't want to find initial speed in any direction. You want to find your initial speed along the line of approach or line of impact. So what is your u in direction of line of impact? It will be u cos 45. And u is given as 10 and cos 45 is 1 by root 2. So your velocity along yellow line or your velocity along line of impact will be 10 root 2. What is this velocity? This is your approach velocity, with which speed it was coming. Okay. Now what about velocity of separation along your line of approach? So velocity of separation. So this is your situation. Your VA is moving in this direction and your VB is moving in this direction. So you can clearly see that your VB is already along line of impact. So what will be the velocity of VB along the line of impact? It will be VB, simple. So what will be the velocity of VB along the line of impact? It will be VB, simple. But what will be your velocity of A along line of impact? So you can clearly see the angle between VA and line of impact is 90. So your velocity of VA along line of impact will be VA cos 90, which is nothing but 0. So your velocity of EA, final velocity of A along the line of impact will be 0. So your overall velocity of separation is VB minus VA cos 90, which is simply 5 root 2. 5 root 2. Now you can easily find the coefficient of restitution. This is velocity of separation, which is comes out to be 5 by root 2, and velocity of approach, which comes out to be 10 by root 2, which is coming out to be half, which is 0.5. So I hope that you have understood this concept, that how do we find the velocity of approach and velocity of separation along the line of approach, along the line of impact line. So it is very important that you find an approach velocity and separation velocity in the direction of impact line. You cannot simply find them in any direction. You have to find them with respect to the impact line. So this was a perfect example to understand this, and this concept is very tricky. And it is not like that you don't need this. I will be discussing TIFR problems and I will be directly using this concept. So this concept is very important. That is why most of the institutions leave this, because this concept is difficult. Even a very good teachers don't know this concept. So, but this concept is directly used in TIFR problem. So I will be discussing 2 TIFR problems, and if you know these 2 problems, then you know any problem. You can solve any problem, because these 2 problems are very advanced problems in itself. TIFR problems are always advanced. So let's do, this is a TIFR PYQ. So let me explain you the problem first, and then I will explain you how to solve it. So let's do the problem. So what is happening is there is a body, and that body is moving down, and that body comes and hit the ground. After hitting the ground, this body will again rebounds, and then it will complete this parabola. And the total, what is asked to you is, what is this total distance AB? So this is your problem. Okay. So the first thing which I want to know is, when it hits the ground, let's say it hits the ground with velocity u. What is that u? With what velocity it will hit the ground? Using work power energy, you know that the potential energy at top, mgh, will be equals to kinetic energy at bottom, which is half mv square. This everyone knows that the total energy at top will be equals to total energy at bottom. So total energy at top is mgh, and there is no kinetic energy at top. So it means that kinetic energy at top is 0. So the total energy at top is mgh equals to, at the bottom there is no potential energy, but there is kinetic energy. So it means half mu square. So mgh equals to half mu square. So from here your u comes out to be under root 2gh. Very nice. Very, very nice. So one thing which we identified is that with what speed your body will come and hit the ground. Okay. So let's draw this much more nicely, that this is your initial velocity. So once the ball come here, it will hit the ground with this velocity u. And this u you have found as under root 2gh. After the collision, what will happen? It will rebound with the speed v. And the coefficient of restitution is given to you, which is 0.5. So coefficient of restitution is given to you 0.5. It means we are sure that this velocity and this velocity will not be equal. That is for sure. Okay. Now I want to give you one more concept, very important concept. That is a concept of common tangent and common normal. So what is common tangent and what is common normal? So we have two vectors. One vector is u vector and another vector is v vector. U vector and v vector. Very nice. We have this situation. What is a common tangent in them? Common tangent is this one. So this is a tangent which is common to them. But what do I mean by? If we see the common point and if we make the tangent to that point, that will be your common tangent. What about the common normal? This is your common normal. So the normal to the common tangent is known as common normal. So this is your common tangent and this is your common normal. The normal to both is known as common normal and the tangent to both is known as common tangent. Okay, fine. Very nice. Now, velocity along common tangent don't change. Always remember, whatever your velocity is along common tangent, it never changes. But your velocity along common normal becomes e times. So whatever is your final common velocity, it is equals to v final along common normal is equals to e times v initial along common normal. So this is your formula. That your final velocity along common normal will be equals to e times your initial velocity along common normal. Okay, let's see this. Okay, let's see the initial velocity. So this is your initial velocity. What is the initial velocity along common tangent? U cos 45. And what is your initial velocity along common normal? It is u sine 45. Simple. What about final velocity? So this is your final velocity. So this will be your velocity along common tangent and this will be your velocity along common normal. So as I mentioned, the velocity along common tangent does not change. So it will still remain u cos 45. What about your velocity along final tangent? Oh, sorry, towards the common normal. It will become e times. So e times u sine 45. Very simple. So then what will be your v? V will be your x square plus y square. So this is your x velocity. This is your y velocity. So what will be your v? V will be x square plus y square ka under root. So if you find that, you get a value as root 5 u by 2 root 2. So this is your velocity after collision. So what we have found now? So you have found that your initial velocity, with what initial velocity was coming, and after collision, with what velocity your object is going. So after collision also you have found your velocity, and before collision also you have found your velocity. Now we will find this distance. Let's say this point is C, and now we will find the distance between C and B. How do we find the distance between C and B? Okay, so you know about the range. Okay, but just before doing that, one more thing which I want to make very sure and very clear, one more thing which I want to find is this angle. Okay, I want to find at what angle this collision, this object will go. Okay, that also I want to find. So how do I find that? So you know tan theta is Vy by Vx. So I can redraw this diagram. So this is your motion, right? After collision, this is your motion. So this is your Vx and this is your Vy. Okay. If you do tan theta, it will come out to be Vy by Vx. Let me redraw here. So this is your Vx and this is your Vy, or I can write this is your Vy. So if you do tan theta, which is perpendicular upon base, so your tan theta will be equals to Vy by Vx. What is Vy? Vy is EU sine 45. So EU sine 45. And what is your Vx? U cos 45. You will cancel and you will get E tan theta. So initial angle was 45. So tan 45 and E is E, which is given to you as half. E is given to you, which is half. So tan 45 is 1. It means your tan theta comes out to be half. So if your tan theta is half, then your sine theta will be 1 by root 5. You can easily find this. I hope that you should be knowing that how, if you know tan theta, how you can find sine theta. And if you know tan theta, how you can find cos theta. If you don't know, please learn this. This is very important. Okay. If you don't know, then you have not a very good basics. Then you should look at the trigonometry, basic trigonometry. What about cos theta? Cos theta will be 2 by root 5. Now let's come to our problem. So we know the angle. It means we know the velocity, we know the angle, and we want to find this distance. What is this distance known as? Range. In motion in 2 dimensions, we covered this. How do we find this distance? This is known as range. So we know this velocity after collision, we know this angle, and we just simply want to find range. The formula for range is V square by G into sine 2 theta. So sine 2 theta I can write as 2 sine theta cos theta. So I just put the value of V, I put the value of sine theta, I put the value of cos theta. Then I get U square by 2G. Then I put the value of U, which is 2GH, and then I will get my range as H. So this range is coming out as H. So let me draw this my final diagram. So your ball came down an inclined plane, it hit the ground, it went in this direction, and this range you have found as H. What about this distance AC? So let's use this triangle tan 45. Let's do this tan 45. It will be equals to perpendicular, which is H, divided by base, which is AC. So what will be AC? AC will be H tan 45, or simply H. So this distance is also H. This distance is also H. So what will be this total distance A to B? This one, H plus H, which is 2H. So what will be your final answer then? The distance AB is equals to 2H. I can guarantee you, this is my guarantee to you, you cannot find any coaching institute which has solved this problem. No one has solved this problem because it is not a cup of tea of everyone. Okay, teaching the concept and then solving the TIFR question is very difficult. Trust me, people cannot solve this. I am able to solve this because I am also a JEE advanced faculty. So I teach the students starting from JEE advanced, NEET, and going till CSIR net. Almost 7 years of physics, 3 years BSc physics, 2 years MSc physics, and 2 years of class 11, 12 physics. I am teaching 7 years of physics every day. So that is why I know a quite huge range of concepts. So this is a concept that you should be using in order to solve such TIFR problems. Okay, now I want to solve just one more TIFR problem before ending this session. I think this will be a good practice. Now, what is question to us? Now, this is also very, very typical problem and no one else has solved this problem. Trust me. So now let's see this problem. How do we solve this? So a body is coming with velocity U and it hits the ground. What will happen after hitting? So the coefficient of restitution is given to you, which is epsilon. What will happen after hitting? Very simple thing. It will hit, it will move like this. Then velocity will decrease because there is a coefficient of restitution. Collision is not perfectly elastic, so velocity will decrease. So it will then move like this, then move like this, and then it will go to the ground. It will stop jumping up. So they are asking what is this total distance? When the body stops moving or when the body starts sliding, means it is not moving up. So after this point, it will slide in this direction. So the point where it starts sliding or stops jumping, what is that distance R? What is that total distance? Very good concept, very typical concept, very beautiful concept. we will be using the results used in the previous question. The formula which we derived in the last question, we will be using that. So we did that, right? You remember we said that final velocity v1. So let's say this is your final velocity, the velocity after collision. The x component of that velocity will be u cos theta. And the y component of that velocity will be eu sin theta. Right? I just want to give you the idea again. So this you can see your x velocity will be u cos 45 because the velocity along common tangent remains same, but the velocity along common normal becomes e times. So after the collision, your velocity along x is u cos theta and your velocity along sine is eu sin theta. I hope that you understood this concept. Now, what next? If we know this, what is the velocity? It is again vx square plus vy square. So this is your velocity after collision. If you know the velocity, what about angle? As I said, tan theta 1, it is vy by vx, which is vy is eu sin theta, which is epsilon u sin theta divided by u cos theta. It will be epsilon tan theta. So this theta 1 is epsilon tan theta. Again, I will do the same thing. If you know tan, then you have to find sine and cos. You can find sine and cos. And now I will be finding the range. So range is, what is the formula for range? 2v1 square by g sine theta 1 cos theta 1. So I will put the value of v1, which I derived here. I will put the value of sine theta. I will put the value of cos theta 1. If I do all of that, everything I did here, I am putting the values here. Okay. If I put these values, then what is the final result which I will get? So let me see if I'm putting it right. Yeah, yes, yes, yeah. So I'm putting this right. So if I put these values here, then what will happen? I can just do some algebra. I can open these squares. I can take u square cos square theta common. Inside it will become 1 plus epsilon square tan square theta. This will cancel each other and you will be left with 2u square by g sin theta cos theta into epsilon. Or I can write epsilon times u square by g into sin 2 theta. So this will be your range 1. What is range 1? Coming from here to here, what is your distance r1? What about range 2? I don't have to again solve it. If the range 1 is epsilon times this, then range 2 will be 1 more times I have to multiply epsilon. So it will become epsilon square. What will be range 3? Range 3 will be epsilon cube into u square by g sine 2 theta and so on. So what will be my total range? I can add all this. So epsilon into u square by g sine 2 theta, epsilon square u square by g sine 2 theta and so on. So what will I get? Epsilon plus epsilon square plus epsilon cube so on. And common power is u square by g sine 2 theta. Fine. Now this is your GP series. What is the formula for summation of GP series? A 1 minus r raised per n divided by 1 minus r. And what is your r? R is a common ratio which is epsilon. So if your r is less than 1, then r raised per infinity is 0. If your r is less than 1, epsilon is less than 1. Epsilon can never be greater than 1. It will always be less than 1. So what will your formula? A is epsilon. So I will put A as epsilon. 1 is 1. R is epsilon. So epsilon raised per infinity divided by 1 minus epsilon. So as I mentioned, if your R is less than 1 or epsilon is less than 1, E raised per epsilon infinity will become 0. And the common is u square by g sine 2 theta. So this will become epsilon u square sine 2 theta. This thing will be 0. So 1 minus epsilon into g. This is your formula. So what I can write is u square by g epsilon by 1 minus epsilon into sine 2 theta. Let's see which option is correct. So your option number D is correct. So you see how the typical problems like this can be solved if we know the concepts. So this is what TIFR wants. The TIFR is asking this question again and again. I can guarantee you there are 2 more questions of TIFR, which I will not be explaining in class, but I will be putting them in the TIFR PYQ questions. You can go to our website and you know that you can solve all the questions in the test format, in the online quiz. So you can actually take an online quiz of TIFR questions of mechanics, or not just mechanics, topic wise, basic mechanics. The questions which were asked from the basic mechanics in TIFR, I have made the quiz for that. So you can take that quiz. In that quiz, there are 2 more collision questions which are also using the same concept. So once you know the concept, the questions will become easy. Okay. So that is all about the collisions class. I will recommend you, please go to our website, read the notes which I am providing about the collision. Those notes are very important. There, it has 30 questions in it. Solve those questions. I will be taking the doubts of those questions in our live doubt class on Sunday. So attend that doubt class and we will discuss all the doubts. Okay. The next concept which I want to tell you is rotational motion, inertia, torque. That I will be discussing tomorrow. So take your time on your collisions. Don't hurry, don't rush, because these questions will directly come in the exam. After our mechanics is done, once we are done with the mechanics, on one day I will take a live class in which I will be solving many mechanics problems. I will be discussing at least 20 problems going from easy to difficult in the live class. So from all the different kind of concepts of the physics. Okay. So see you all. See you in the next class. I hope that you enjoyed this session and you are enjoying the foundation physics course. So goodbye, everyone. See you all.